Alright, so this is a suggestion via donation. The name of the video is this the real reason weather is getting wilder? This is coming from PBS Terra. Let's check it out.
So much extreme weather recently that it's hard to keep up with all the records that have been broken. In fact, in 2021, 10.6% of all weather stations recorded record temperatures. It's easy to blame global warming, but extremes have not only become hotter and drier, they've also gotten wetter, snowier, windier, and colder. So we have to dig a bit deeper to understand why and where these extremes are happening so that we can prepare for what's actually coming our way. In this episode, we're going to explore groundbreaking new research that reveals one common factor connecting almost all of these extremes and even suggests what we can expect in the future. And to do this, we'll start by zooming out, way out to the troposphere. Then we're going back in time by drilling into Greenland's ice sheet to uncover clues about our very uncertain future. The changes we experience in our climate and weather are fascinating and definitely overwhelming at times. But the more we understand about what's happening both today and down the road, the safer we can be.
Yeah, I definitely would not call them extremely fascinating. I mean, I guess they are potentially, guys, right? But I do not like what's happening. I have gone outside probably one time this week, and unfortunately, I had gone outside. All right, I definitely did not enjoy that. The fact that it was 106 degrees. I don't like it, guys. I don't like feeling this hot all the time.
If you want to see more content on changing weather and how to prepare, give us a like and subscribe. Let's dive in.
Let's go, guys.
The jet stream is this meandering, waving, buckling band of west to east moving winds that are situated in the mid-latitudes. And they're really important for us as humans in our day-to-day lives because the jet stream seems to dictate much of the weather that we experience. So any change in weather that we have actually is related to how these upper atmosphere winds are changing.
And as we'll see, shifts in the jet stream connect most of the extremes we saw in 2021. The jet stream forms where warm air from the tropics meets cold air from the poles, and it moves weather systems from west to east due to the rotation of the Earth. Without it, we'd see far fewer changes in our daily weather. Exactly how much effect climate change has on the jet stream is hotly debated, but Judah Cohen is a climate researcher whose work focuses on this exact question.
Strength of the jet stream is very much dependent on how large is that temperature difference between the equator and the North Pole. The Arctic is warming 2 to 3 times faster than the rest of the globe.
That's the reason why we're encountering some rising sea levels at certain parts.
So that means that temperature difference is slackening or weakening. With a weaker temperature difference, also the jet stream is kind of weakening or slackening. The winds are not as fast. Now that I think everybody agrees on. But there is kind of this new idea that really didn't exist 10 years ago, that this weaker jet stream also leads to slower moving weather systems and also a more amplified or greater
responses to said weather
inside
systems.
The jet streams. If the waves in the jet stream have much larger north to south extent, there's much more vigorous mixing of air masses. So you bring cold air from let's say the Arctic or in Alaska County, bring it down to Texas and Georgia, right? And so,
guys, please do that exact thing. We need to, cool down a little bit in Georgia, guys. It's excessive.
It's very anomalous. If it's cold in Fairbanks, they can handle it. They're used to it. When that same cold air is quickly transported into Dallas, Texas, or Atlanta, Georgia, they're not used to it, and it causes havoc with our infrastructure.
I'll give you that.
Right.
Right.
This theory
because Georgia is very specifically cannot deal with any type of snow. If snow hits Georgia, everything is shut down, guys. And I'm talking about like a light dusting. Like growing up in New York, snow did not shut down the school, guys. Unfortunately, a light dusting of snow in the South just shuts down everything. They cannot function, guys.
May be new, but 2021 made a pretty convincing case. In fact, it's hard to find examples of major weather events from last year that aren't connected to the changes in the jet stream. The Texas deep freeze was caused by the jet stream becoming so wavy that it brought Arctic air from the poles to the southern U.S. Later, the jet stream was so coiled and slow over the Pacific Northwest that it trapped a high-pressure system over that region, allowing hot summer sun to heat stagnant air to new highs. A similar pattern caused flooding in Europe and fires in Siberia. Then, Hurricane Ida slowed as it hit the Gulf states, and instead of being pushed offshore by atmospheric winds, it was blocked by a high-pressure system and dropped record rain over the eastern U.S.
So, I mean, how do we build resiliency to climate change? And it really will come down to, a large part, changes to extreme weather. And again, extreme weather is very much strongly connected to changes in the jet stream.
Okay, and that is happening more.
I mean, that's probably the answer to the entire question. We're like halfway in, and he, for the most part, just gave us the answer. The reason why things are so crazy, everything is jet stream oriented. Obviously, you know, some type of climactic change is also playing a part, potentially, guys, right? Absolutely. But it's more jet stream oriented. Maybe that is a common thing that happens on the planet maybe every couple thousand years, and we just haven't been around long enough to pay attention to that, guys, potentially.
Because of Arctic amplification, correct?
So that, you know, this is a controversial idea. That's an argument that I'm making.
And Judah is
good.
not alone. So
Feels
we'll
good.
see in the coming years how this debate plays out. But it's not just wind direction and speed that can change. In fact, the entire system might be migrating, which could mean even more significant and long-lasting changes to our climate at ground level. Matthew Osman from the University of Arizona's Climate Systems Center recently discovered chilling data that suggests the jet stream is moving north.
If we want to understand how climate change is going to evolve in the future, we need to understand how and why it has changed in the past.
Okay, so how do you figure out climate changes and jet stream locations before satellites were documenting them?
So in this case, what my team was able to do was to collect measurements of glacial ice from across Greenland and combine those measurements together in order to dissect properties of the climate that are related to changes in the jet stream.
Yeah, I definitely do not like the concept of like core sampling things, specifically ice. Like, I understand that you're getting exactly what they're doing, right? They're trying to see whatever was happening those many years back in time when, you know, when they're pulling this core from, right? But guys, there could have been some type of global disaster that took place before we existed. And by coring this thing, you're bringing a very specific year that the Earth would like to forget, mainly, I don't know, maybe 536 potentially, most likely, right? Either way, we're trying to forget this one thing happened in our past. Okay, so what's going on here? Anyway, do we really need to bring that back to where we are now, guys, to the present? No, right? Should we know for science? I guess, right? But I just don't want you bringing back some like rare form of like anthrax or something, guys. I just don't want it.
By doing this,
Personally,
they
we
were
don't
able to
need
find
another
changes in the jet stream's position and
shutdown.
intensity going back 1,200 years. And they found evidence of big changes.
Going back 1,000 years into the past, we see that changes in where it's positioned across space can be on the order of 10 or more degrees latitude. So this is a lot of area that the jet stream is covering,
Right.
On these really long time scales. And this, of course, has big impacts on changes in weather that we've seen over the last millennium.
Over the last 100 years, we've been emitting greenhouse gases into the atmosphere, causing the climate to warm. And remember, the jet stream is created where warm southern air meets cold northern air. And if the Earth warms, then the place where those air masses collide might move north because there's less cold air.
So what we've seen is this slight trending of the jet stream's position towards the north over the last 40 years, but it hasn't been clear whether or not this is driven by natural changes or whether this is human caused.
And one convincing
And that's, I think, the dilemma with a lot of people. Like, I mean, we can sit here and talk about the things that humans are doing to the planet, absolutely. But if the jet streams are changing, I'm not sure humans are creating the jet streams, Chris. I am not sure about that. I think that's probably at random. It feels like it may be. And everyone got really comfortable with it being a very specific way for the last 1,000 years, guys, right? Or a couple thousand years. To the point where everyone started building all these civilizations in places where, 1,000, 2,000 years ago, those places probably should have not been inhabited, guys. All right? But either way, and this is, I'm guessing, the reason why we are now all suffering from these crazy weather events.
Way to separate
Tornadoes in places where they've never been. Hurricanes hitting, at levels where we've never seen. Tiny island nations are basically being decimated by things. Oh God, guys. I think, honestly, by hearing this, it's most likely jet stream oriented, guys. That's where we are.
human-caused jet stream migration from its natural variability is that the jet stream's average location goes outside of the historic range.
And what we can do is actually compare projected changes in the jet stream that we get from models with the range of variability that we see in our reconstruction. This is essentially the range of natural variability. And what we see is that for high greenhouse gas emission scenarios, we might find ourselves in a position where the jet stream becomes effectively distinct from the range of natural variability within the coming decades by as early as 2060 CE. Observations that we have from satellites, as well as estimates of the climate system that we get from models, both agree that the onset of changes in the jet stream's position has already began. It probably began about 20 years ago in the late 20th century.
Okay.
And this is really...
And I'm guessing that's around the time where people started heavily speaking about changing climate.
Important because when we start to think about climate extremes, right? So extremes in precipitation or temperature, we care about where the edges of those variations exist.
This is because as the jet stream migrates beyond the limits of its historic range, we're likely to see even greater extremes in our climate than we're used to.
If we continue to emit greenhouse gases, we will see a migration of the jet stream further
Faster.
and further to the north. And as we push the North Atlantic jet stream outside its natural range, we will see consequences in where the temperature extremes as well as precipitation extremes fall for the places where you and I live today.
If this
Right.
pattern continues to play out, places like California and much of the American Southwest will keep getting hotter and drier as the jet stream delivers less and less moisture from the ocean, while some more temperate regions like the Pacific Northwest will receive even more moisture than they currently do.
This means many already dry regions becoming drier and wet regions becoming wetter. And the same pattern would likely hold true across much of southern and northern Europe. Our understanding of these changes.
Yeah, because so half the year I'm in Spain and then the other half I'm in the United States. I can definitely tell you that things are also changing for the most part in the south of Spain, guys. Temperature is getting a little crazier. It's getting hotter. Guys, there are times where the temperature is like 115 degrees Fahrenheit. It is not a fun place to be, in the dead of summer. In a country where, central air is not like super common to have in your household. Like you may have like one of those small, I call them European air conditioners, guys. They sit on a wall right next to the window and they just drip liquid all day, that type of thing, right? Yeah, guys, it's rough out there during the summertime. And I definitely do not want it to get hotter in either of these places, guys. Absolutely not.
Is still evolving, but Matt
It'll
and
get
Drew's
colder.
work underscores the need for preparation. And
prefer
I, for
cold.
one, feel
Absolutely.
a lot better when I understand and when I'm ready for what's coming our way. For a deeper dive on how to cope, check out our previous episodes on drought, flooding, and winter weather. And finally, we'd love to hear what you think about this subject, as well as what other weather and climate topics you'd like for us to cover in the future.
To be honest, I think you basically answered any question I had. Right? I mean, obviously, I never really dug too deeply into the topic. I just, thought it is kind of is what it is in this instance here, right? But if it is jet stream oriented, and obviously we're escalating the issue that was already probably going to happen anyway, guys, right? We are escalating the issue with our greenhouse gases, let's say. But all right, listen. Let me know in the comments of the next thing I should be checking out, and I will get to that as soon as I possibly can. All right, then listen, you guys all have an absolutely amazing day, and enjoy your day thoroughly.